Hello, welcome again. We are solving some questions of fluid mechanics and machinery. Question number 12 and 13 has common statement. The statement is a tank contains water up to height of 0.5 meter above the base. An immiscible liquid of specific gravity 0.8 is filled on the top of water up to 1 meter height. Each side of the tank is 2 meter wide. Question number 12 is the total force on one side of the tank is option A 7848 Newton, option B 15696 Newton, option C 24525 Newton, option D 18148.5 Newton. Question number 13 is position of center of pressure for one side from top is option A 0.5 meter, option B 1.25 meter, option C 1.35 meter, option D 1.009 meter. Okay, so given that the depth of water is 0.5 meter and depth of liquid is 1 meter, so this is your tank. This depth is 0.5 meter and this is 1 meter, and specific gravity of liquid is 0.8. Okay, we have to, in first question we have to determine the total force on one side of the, or total pressure on one side of the tank. Okay, so specific gravity is zero point 0.8 and density is density of liquid is specific gravity of liquid is zero point 0.8, so density of liquid will be that is on the top part is 800 and density of water is 1000. Okay, width of tank is 2 meters. So width of tank is 2 meters. Okay, so this is your so here the pressure is 0. Okay, so as we go down we have to calculate the force on the one side. So this is your one side. As we go down the pressure will go on increase, the pressure will increase. Okay, and the pressure will be 0.8 gh. Okay, 0.0 gh or 800 gh. Okay, so that pressure will be 7848. Okay, and now the further there is at the bottom there is water, so this is water. Okay, and and there will be increase in pressure due to this also, and up to that, so at that point at the bottom the pressure will be summation of these two. So at the top sorry at this point at certain d the pressure is rho gh, rho 1 gh, that is 800 into 9.81 into 1. Okay, okay, now at this at the bottom the pressure will be summation of this pressure plus this pressure. Rho 1 gh1 is already calculated as 7848 and it is water, so it is rho 2 gh2 and this distance is 0.5 meter and 1009.81 into 0.5. Okay, so that is 12753 Newton per meter cube. So intensity of pressure at the bottom is 12753 Newton per meter cube. Okay, okay, now the force F1. Now we have drawn the pressure diagram. The force on different portion can be determined by calculating the area and multiplying by width. Okay, so the area of this portion is 7848 into 1 by 2 triangle. Okay, so that will be 7848. So force in this force due to this liquid will be F1, that is 7848, and force due to these are here the area of this rectangle, that is 7848 into 0.5, 7848 into 0.5, and width of tank is 2, so that is 7848. Okay, so now this is your F, and again this is your force due to this portion is given by F3, so that is 4905 into 0.5. Okay, 4 into 2, so 4905.5 into 2 into 2, so that is 2452.5. So the total pressure will be F1 plus F2 plus F3. F1 is 7848, F2 is again 7848, and F3 2452.5, that is 18148.5 meters. So total force will be, or total here it is saying it is force to pressure. Total force will be F1 plus F2 plus F3. Okay, so that will be your summation of this 7848, 7848 and 2452.9. Okay, so just we have to calculate the areas, okay, and total area, and multiply by this. That will give force. Okay. Now the second question is determine the position of center of pressure from the top. Suppose the center of pressure is lying at H star. Okay. So then moment about the center of pressure of total force will be F into H star, and that moment will be same, that is individual moment of each force. So as the center of this triangle is at 2 by 3 from, or 2 by 3 h from top, so that is 2 by 3 into AD, and this AD, this is AD, and the center of this is AD plus 0.5 by 2 plus 0.5 by 2, or AD, okay, and center of this is AD plus 2 by 3.5, okay, or BD. So putting the values, we have F, we have F1, we have F2, we have F3, we have AD, AD is 1 meter and BD is 0.5. Putting the values, we can get S star as 1.009 meter from top. So answer is 1.009 meter from top. So that is the method to find out the total force. Draw the pressure diagram and find the area multiplied by weight. That is force. And to find out moment, let H star be the center of to find out center pressure, let H star be the center of pressure from top, and multiply each force, take moment of each force about this point. So that will be F into 2 by 3. Okay. Okay. So total resultant moment will be equal to resultant of each individual moment. Okay.